Hello guys. In this video, we are going to discuss the solution of the problem brackets in matrix chain multiplication. Well, the problem statement is a bit lengthy. You can go on it on your own. What I will do is basically I'll explain the problem statement and then we will go ahead and discuss the solution for it. So let me explain the problem statement first. Okay. So what is given to us is basically an n is given to us, and let us say n is equals to 4, and a p matrix is given to us. Okay, and let us say the p array is given to us, and let us say the content of p array is 1, 2, 3 and 4. So n simply means the size of array p. Okay, so now if n is equals to if n is given, so here the number of matrices, right, matrices equals to n minus 1. So in this particular case the number of matrices are 3. And let us say those three matrices are A, B, and C. And the dimension of this matrix is given in this particular array, right? So let us say A is my first matrix, then the dimension is 1 by, okay? B is my second matrix, the dimension is 2 by 3, all right? C is my third matrix, and the dimension is 3 by 4, okay? So this is what P array n simply means. Given these matrices, right, what we have to do is basically we need to perform multiplication operation. Okay, so like we don't have to multiply the matrices, but what we need to do is that, like, let us say we have these ABC matrices with us, we need to perform multiplication. Now since matrix multiplication is associative in nature, so what that simply means is basically you either perform AB and then you multiply the resultant by C, or you perform BC first and then you multiply the resultant with A. These two are equivalent. Equivalent in the sense the result you will get is same, right? So what is our objective is, now we know that there are multiple ways to perform multiplication operation, right? Here let us say the number of multiplication operation which required in order to compute matrix multiplication in this way would be something, and here it would be something. So let us calculate the number of multiplication we need to perform if we go by this, right? So the matrix dimension, let us say, is 1 by 2, right? And the other matrix is B, the dimension is 2 by 3. So the number of multiplication we need to perform is 1 by 2 into 3. Okay, and the resultant we have to multiply it with C, right? So if we multiply A by B, the resultant matrix which we will get, right, A into B, the resultant matrix dimension we will get is 1 by 3, right? Right, and C is of dimension 3 by 4. So if we have to multiply the resultant of this by C, then the number of multiplication we need to perform is 1 by 3 into 4. Let me just write it down. 6 plus 12. In this particular case, 18 matrix multiplication we have to do, or 18 multiplication operation we need to perform. And if we perform multiplication in this way, so the number of multiplication we need to perform is B into C, so which is equals to 2 into 3 into 4, plus the resultant we have to multiply it with A, so which is equals to 1 into 2 into, right, 4, right? The resultant will be of B and C will be B into C. The dimension will be what? 2 by 4. So here the number of multiplication we need to perform is 20 plus 8, which is equals to 32. So clearly, if we go with this approach, right, if we go with this approach, the number of multiplication we need to perform is less, which is 18, right? So for this particular case, the answer we need to return is A, B and C, right? Which simply means we will perform AB multiplication first, and then the resultant is something which we are going to multiply it with C. All right. So that's about the problem statement, folks. Now let us discuss the solution for this problem. So the brute force solution is very primitive. like the brute force solution should be, and which is basically what we have to do is, let us say n is given to us and p array is given to us. So we know n minus 1 matrices would be there, right? This is the number of matrices which we will have. And let us say, let us take some concrete example. So let us say n is equals to 4. Okay, so the number of matrices is basically equals to 3, and which are a, b, and c. So what we are going to do in the brute force solution is basically we are going to generate all possible ways by which I'll be able to multiply it, right? So here, when the possible ways are this, right? And the other possible way is this, right? And then we will generate this all the possible ways, and then we will compute for individually what is the number of multiplication we need. So here we will check the number of multiplication operation we need to perform, right? And similarly here also we are going to check the number of multiplication operation we need to perform, right? We will check that, and the minimum of these two, the one, let us say this is minimum, so we are going to return this particular thing over there, okay, as an our answer. Okay, so that's about the brute force solution, which requires generation of all possible combination, and generation of all possible combination will be exponential in nature. All right, so that's the brute force solution. Now let us look at the optimal solution for this and how we are going to solve this problem optimally. So let us discuss the optimal solution, right? So let's start with the very base case uh, when n is equals to 3 and the matrix P contains 1, 2, and 3. Okay, so and here we know that the number of matrices will be how much? N minus 1. So this here it will be 2. So the matrix which is available to us is A and B, right? And for A and B, if we have to multiply, there is just one way possible, and which is equals to AB. Okay. Now let us say we move to we increase our input size, right? And now here let us say the number of matrices. Here the number of matrices is 3, right? So here if the number of matrices is 3, then we have A, B, C with us, right? And then this A, B, and C, what are the possible ways by which we will be able to multiply? Well, there are two possible ways, right? A and then B and C, and the other possible way will be basically what? You multiply AB first, and then the resultant you multiply with C. Okay. Now let's take the third case where the number of matrices is 4. Okay. So if the number of matrices is 4, then we have A, B, C, and D. Now the complication occurs, right? So what are the possible ways by which I'll be able to multiply it? So one very easy way to solve this problem is consider this to be a partitioning problem. So what we can do is A, B, C, and D is given to us. What we can do is that we can partition it at this position, right? So that simply means we will perform BCD first and then AB, then multiply it with resultant, right? The other way could be you put a partition over here, right? So initially you put after A, then you put after B, right? So this simply means you perform this, and then you perform. So you perform AB first, then CD first, and then you perform the multiplication of those two resultant. The third option would be, right, will be to put a partition over here. So this will be ABC, and this is D, and then this is how we need to multiply, right? Now here if you see this BCD, right? Now BCD again can be partition, and for BCD to partition we have already solved this, right? Number of matrices, if the number of matrices is 3, then these are the two possible ways. So let us plug that. So basically this will be A, so one way will be B, C and D, right? So this is one way. The other way will be what? A, then you multiply B and C, and then you multiply it with the resultant D, and then so on, right? Similarly, so here there is just one, right? There is no other way. We cannot break it further for this particular case. And for this particular case, again, we have the same sub problem, right? The number of matrices is 3 over here. So we can break it into like this, A, B, C. So this will be my 1, and then I will multiply it with D. The other way will be what? You multiply AB first, okay? Then you multiply it with resultant C, and then you do it with D. So you see, like here how we were able to, first we did this, and then from here how we were able to expand to this position, right? So what I wanted to do with this is basically I wanted to establish the fact that there is a sub problem, right? Sub problem, and these sub problem are repeating in nature, right? So what do I mean by this is that here when the number of matrices were 3, so if the number of matrices were 3, then there exists a subproblem which we need to solve, which is of size 2, right? Similarly, here when the number of matrices were 4, then there exists subproblems of size lesser than 4, which is 3, right? You see this, right? And 2 also, and 2 is the subproblem which we have already solved, right? So from here, what I'm trying to come to, or what logic I'm trying to deduce is basically, if we solve a smaller subproblem, if we start solving by smaller subproblem, and once we have solved all the subproblem of a particular size and we move to a higher subproblem, then we can rely on the solution or the whatever subproblem we have solved for a smaller size in order to construct the solution of the bigger set. Okay, so that's the logic here which we are going to use. And this, if you see, this is a classical case of dynamic programming, and this is what we are going to use here. Okay, so let us see how we will be able to use dynamic programming in order to solve this problem. So the first thing which we need is a DP table. Okay, and in this particular case we need a DP table of n by number of matrices, which is n by minus 1. So this will be the size of this DP table, n minus by n minus. Okay, what it simply means is basically, uh, let me just write it down. So the matrix A, let me just have it like this: matrix A, matrix B, matrix C, and matrix D. Okay, so I'm solving for n is equals to 5 here. So the number of matrices will be 4, and these are the 4 matrices which I have. Here also it is A, B, let me just increase the size here a little bit, and C, and then comes our D. Okay, so these are the matrices which are there with us. Now what entry over here simply means, right? So let us say like here. So let me just write down the indexes as well so that it will be a bit clear. So here let's say the indexes will be 0, 1 and 2, 3. Here also 0, 1, 2 and 3. Okay, so what does a DP, and let's just have it like this, 0 comma 1 means, right? So DP 0 comma 1 means, so 0, if you see, right, 0 is what? A, and B is what? 1 is what? B, right? So this simply means A into B we are performing, and the number of the minimum number or the most efficient way by which I am able to perform A comma B is something which will be there in this particular DP table. So DP 0 comma 2, right? So what this simply means is that I am trying to perform a multiplication of A to C. right? So 0 is what? A, and 2 is what? C. So I want to perform A into B into C, right? This is what I want to perform. And the minimum or the most optimal way by which I'll be able to perform this multiplication is something which will be there in the table dp0, 2. So what I'm trying to say is dp of I, j will hold the minimum um, minimum number of multiplication operation operation, okay, one need to perform need to perform to multiply ith I plus 1th. Okay, let me just write it down like this: I plus 1th, I plus 2th, all the way till jth matrix. Okay, so the minimum number of multiplication which one needs to perform in order to multiply all the matrices from I to j is something which will be there in the dpi, j table. All right, so that is what it will be. Now let us see how are we going to populate this table. So let's take that. So here, let's have this. So the p which is given to us, n equals to 5, and let's quickly just write down the p. The p which we have is 1, 2, 3, 4, and 5. Okay. So the first thing, a by a is not possible, right? A by a is not something which we want to achieve. Similarly, b by b is not something we want to achieve. C by c we don't want to achieve. D by d we don't want to achieve, right? Or we don't want to perform. So these entries will not contain anything. The other thing which, so now let us, what should be the value over here, right? So we want to perform a by b. Okay, let me just go here. Let's take a new page. And let me just write down the matrices as well. So, it will be 4 and 5. So what we want to do is that we want to perform A by B. Now A by B is the base case. Base case here, like we just want to multiply two matrices, and this is the starting case. So here what we are going to do is when we just have to perform multiplication between two matrices, so that will be given by, basically the dimension is 1 by 2 for A, and the dimension for B is 2 by 3. So the matrix will be 1 by 2 into 2 by 3, which is equals to 6, right? So what I am trying to say is, if we need to multiply two matrices, then, right, then dp of I, j will be given by how much? By what value we have to multiply? So dp of I, j will be given by pi, right? So the ith matrix dimension is where? Pi plus 1, right? And the jth matrix dimension is where? J and j plus 1. And if you see, right, I plus 1, this is j and this is j plus 1. So I is like this, I plus 1 and j is same. This will be j plus 1, right? If we need to multiply only two matrices, and the way we are going to do is basically here. So we are going to fill these columns first, these elements first. Once we have filled these elements, then we are going to fill these elements, and then at the last we will be going to fill this element. So let us see what should be the value over here. So here we have seen that a into b we have to do. So a and b, in order to multiply a and b, how much value we need? 6, right? 6. And there is just one way by which we will be able to perform this matrix multiplication, which is this, right? So we will have each entries will have two values associated to it. One which represents the minimum number of multiplication which we want to perform, which is 6 in this particular case, and the way the multiplication will occur, A and B. Similarly, if you want to perform B and C, then from this formula, if you see, right, from this formula we know that we just need to multiply that. Okay, so B and C is what? 2 into 3 into 4. So this will be what? This will be equals to 24, and there is just one way, which is B into C. Okay, now let us do other um, the other thing as well, which is C into D. Let us fill this entry. So C into D, if we do, this is basically 3 into 4 into 5, which is what? 60. Okay, let me just write it down over here. So this is 60, and there is just one way, which is C into D. So this we have filled it. Now let us look at the complicated cases where we have to perform multiplication for between more than two matrices. So here, if you see this, we want to perform multiplication between A to C. So here, what we want to do is we want to perform multiplication between A, B, and C. So now what we will do is here, now we know again, remember the partitioning. So one partition we can do is here. So this we will partition it over here, B and C. And the other partitioning we will do is here, right? A, B, and C. So now let us calculate the number of multiplication we need to perform. So B and C, right? So B and C is something which we have already solved. The number of multiplication operation we need in order to perform B into C. So let us check that value. So this was this, right? So that will be 24. So here 24 operation will be needed. Plus, then the resultant we need to multiply it with A, right? Let us multiply the resultant with A. So B into C, if you perform, B and C if you perform, you will get a matrix of B into C. If you do, you will get a matrix of 2 by 4, right? And A, the dimension is 1 by 2. So the resultant, if you do A, B, and C, we will get 1 by 4. Okay. So here, what we have to do is, so let's just do it 1 into the number of multiplication 1, and then 2 into 4. So here in this particular case, this is 24 plus 8, which is equals to 32. Okay. And in this particular case, let us say when we are going by A into B and then C. So A and B, what is the minimum number of matrix multiplication we need? This problem we have solved it. A into B, we require just 6. So this will be 6, right? 6 plus A and B, right? When we are doing A into B, when we are doing A into B, the resultant matrix will be what? 1 by 3. And then we are multiplying it with C, and the what is the C is basically what? 3 by 4, right? So now how much we will need? 1 into 3 into 4. So this is basically 6 plus 12, which is equals to 18. So here, this is what we have to do, right? So first we have to perform AB, then we have to multiply it with. So here basically when we are filling this value, what we will do is 18 is the minimum, and what is the other entry? Well, the right way to do it is this. Okay. Now let us fill this this one, right? So this entry is what? You want to multiply from B all the way till D. So let us do it. We want to multiply B. Okay, let me just write it down like this: B, C, D. So again, here also where we have two ways, like B, C, D, and B, C, and then U, D, right? So here, if you calculate it, what you will get is basically, let me just write it down here. So here, if you see, this will be BC is something which we have already solved, and if you look up, BC is what? 24. So 24 And if you solve it further, what you will get is this is basically equals to so let's just solve this. Okay, I don't want to. So B and C. So if you do B into C, so matrix of B is 2 by 3 and C is what? Okay, 3 by 4. So what we get is basically B into C. If you do, you'll get a matrix of size 2 by 4. And A is of size what? 1 by 2, right? So then if you want to perform, sorry, we had to do it with D. So D is what? 4 by 5. I'm sorry. So 4 by 5. So you need to perform BC and then you have to multiply it with D. So here the number of multiplication we need is 2, 4 and 5. Right. So this is basically equals to 24 plus 40, which is equals to 64. Okay. And if you do it in this way, so CD is, so CD again, this is a sub problem which we have already solved. So CD, let us take it from there. CD is what? 60. So 60 plus, if you solve it further, how much you will get is basically 2 into 3 into 5. Okay. And this will be equals to 90. Okay. So here you see this is the most efficient way. So we will take this, so which is BC first, and then you multiply it with D. So let us write it down. So here it will be what? 64. And then you need to perform, and what is, and how you are going to get this? BC first and then D. Okay. Now let us look at this. So here you want to perform all the way from A, B, C and D, right? So here again, let us go with the partitioning logic. A, B, C, D, then A, B, then I can put a partition here, C, D, then A, B, C, then I can put a partition here, which is D. Okay. So here if you see, so see this BCD you have solved it, AB you have solved it, CD you have solved it, ABC you have solved it, D you have solved it. Sorry, D is something individual, so not a problem. So A into BCD, and what is the right way of multiplying BCD? So the right way of multiplying BCD is what? BCD is 64, right? So this is what we are going to use. So this will be like basically this will be what? 64 plus the number of multiplication we need to do is 1, 2 and 4, right? 1, 2 and 5, right? Yes, 1, 2 and 5, right? So this will be equals to 64 plus 10, which is equals to 74. All right. This is something which we have to understand it little bit more carefully, because here we need to perform one more operation. So see, AB we have solved it, CD we have solved it, right? And AB what? AB is, let's just look at AB and CD. AB is what? AB is 6, and see this, AB is 6 and CD is 60. Let's use that. 6 plus 60 plus, right? Because here what this simply means is we have to perform AB, then you have to perform CD, and then once these two have been done, then you have to multiply all these two, right? So AB is this, CD is this, but this into this we have to find it out. So what will be the value here? So A into B, if you do it, so you will get a matrix of 1 by 3. C into D, if you do it, what will be the dimension here? I think 3 by 5. So here what you will get is 1 into 3 into 5. So here how much will be the value? 6 plus 60 plus 15, right? Which is equals to 81. And this is, so here you have to be careful, right? Little bit care is needed. You have to do this, and then you have to multiply. You have to have this value added as well. Okay. Let's look at this. So ABC we have already solved it. Let me just look that. ABC we have already solved it, and that is 18. So this is 18. and then you have to multiply this resultant with D. So if you solve A, B, C, you'll get a matrix of size 1 by 2, 2 by 3. So that is, I think, 1 by 3. And then, and then this is 3 by 5. So this is, okay, 18 plus 15, right? I think I'm missing something. I think this will be 1 by 4. Okay. So this will be 18 plus 20, and this will be equals to 38. So the right way is basically A, B, C, and D. So the minimum here is 38, right? So the right way is A, B, C, and D, right? Let's do that. So we know we have to do A, B, C, and then we have to multiply it with D, right? And what is the right way of doing ABC? The right way of doing ABC is you multiply AB first and then C, right? Okay. And this is what we are going to return. So once we have populated our DP table, this entry is what we are going to return as our answer. Okay. So that's about the discussion, folks. Now let us go through the code in order to understand how we could code it. So I have already coded it. So let's see how we have coded it. So the first thing is that we need a table of n minus 1 to n minus 1. So here I have used it as n, but n minus 1 is what we need. Okay. Then we need to have a string of ABCD. So I just wanted to generate ABCD, like the name of the matrices, and this is how I have generated it. So this basically what will happen after this. Towards the end, depending upon n, this string will contain A, B, C, D, E. I mean, depending upon this n, this will contain the n minus 1 matrices with it. Okay. Now this is where we are doing our operation. So first thing we need to understand is that we need to traverse the diagonally, right? We need to traverse our matrix diagonally. Like, it's not the traditional way where row by row we are going it, or column by column. We have to move in a lateral or a dimensional way. So in order to do that, this is how you can do it. So you have it like I is equals to 0 and j equals to k plus 1, and then you increase I and j both, right, after performing. So 0 comma 1 is the start, and once 0 comma 1 has been iterated on, then you go ahead and increase the value of I and j both. So after 0 comma 1 it will be 1 comma 2, which is the next entry diagonally. So that is what I wanted to emphasize on, that you need to iterate on diagonally, and this is how one can iterate on diagonal matrix. Okay. So once we have iterated on diagonally, this particular thing is where we are performing multiplication if the number of matrices, right? So here, so j minus I plus 1, which gives me the number of matrix I want to multiply, right? So let us take a concrete example. So 0 comma 1, right? So j is 1, I is 0. So 1 minus 0 plus 1 is 2, which is equals to 2. So like a into b we want to perform here. So if a into b, then you recall it from our discussion. This is how you'll be able to do it. And so here the DP table, right? Let me just go over here. When we are initializing the DP table, we are having two entries over here, right? One is the minimum number of multiplication, and the other entry is basically the answer, right? The most optimal way we have to multiply. Okay, so that is what the number of multiplication will be given by this. And since this is just multiplication between two matrices, which is string I and string j, and then you enclose it with bracket. Okay, and this is something like 0 comma 1, so 1 comma 0 will also have the same entry. All right, so that's about the 2 when the number of matrices are 2. If the number of matrices are more than 2, then remember our partitioning logic. So I want to multiply matrices from I to j, and the partition I'll do is at lth. So the first partition I'll do is at ith index, then I plus 1th index, and so on all the way till jth index or j minus 1th index. Okay, and here is a bit of tricky logic, or that is the way we can do it, is is basically value equals to, so like what I mean to say is, um, let me just go here in order to explain this. So what I have done here is, let me take a new page. So what I have done over here is, so let us say we want to multiply matrix A, B, and C, right? So this is 0, this is 1, and this is 2. Okay. So now A, B, and C, the way we were able to do it is like you put a partition over here, and then you put a partition over here, right? So what simply means is, so basically when now like I equals to 0, j is equals to 2, right? And L is where I am putting a partition. So I can put a partition at 0 and I can put a partition at 1, right? Okay, so what it simply means is A, and then this is partition at 0th position, and this is partition at 1th position. Okay, so what happens is like now we have I, L, and J. All right, remember this, I had I and J matrix, and then I am partitioning by with L. So now I have I, L, and J. So what this simply means is basically I have a range of I from I L plus, sorry, L till L. Let me just write it down like L, I to L. So I to J range I have divided in I to L and then L plus 1 to J. Okay, this we understand. Then now let us take some concrete example. Let us say I equals to 0 and J is equals to 2, right? And then L equals to 0 or 1, right? So we get what? 0, 0. So I'm trying to write it as this I, L, and J. So I, L, and J is what? 0, 0, and 2. That is 1. And the other will be I, L, and J will be 0, 1, and 2, right? So what will happen is basically it could be like an overlapping over here, right? So I and L are equal here, and J plus 1 and L are equal here. Sorry, L plus, so here I is equals to L, and here L plus 1 is equals to J, right? So here basically we will get 4 cases, right? When I is equals to L and I is not equals to L, right? That is this is case 1, this is case 2. When L plus 1 equals to J, which is case 3, and when L plus 1 is not equals to J, this is case 4, right? So these are the 4 cases we will get, and these 4 cases we will uh, solve it like this, right? So for case 1, right, the for case 1 when I is equals to L, so the this will be basically pi into pi plus 1 into p of j plus, right? So why is it so? Let us look at that also. So here basically I is equal to L, right? So so here let us say like A, and then this is basically this case, right? A, and then partition it with B and C. So what we have to do, BC we have to do, right? And then the resultant, right? So you remember like if you see this like BC, right? So BC is what, like 2 into, so BC is something which we already have, right? So let's just look at that. So BC is what? 24. Okay, BC is 24, you remember. So this is what we want to do. So BC is 24, and then the resultant you have to multiply 1, 2, and 4, right? So 24 is fine, you can write it down as such. 24 is fine, plus this portion, right? This portion which we have find it out like 1 into 2 into 4, which is like multiplying A with the resultant matrix, is something which will be given by this formula, right? So ith matrix, so the ith matrix dimension, which is 1 by 2, and jth matrix. Sorry, so the jth matrix dimension is where j and j plus 1. So j plus 1. So this is 1, 2, and I think maybe 4 or some value was there. What was the value? Let's just check it. ABC, yeah, that was 4. So that is how you will multiply and you will get 32. Okay, so similarly you can pause here and look at the code, and you will be able to figure out what are the cases I have covered over here. All right, so let me go back. So this will be our case 1, this will be our case 2, and this will be our case 3, and this will be our case 4, right? And this particular case, right, this is a separate case where you remember when we were trying to multiply A, B, C, D, and the partition was like after AB, right? So AB you multiply and CD you multiply, and then you multiply the resultant, right? So that particular case will be here. Okay, and then you basically you perform for all the combination, you try to compute the minimum. Whatever is the minimum, you update it in CPI comma J, and towards the end you return this particular value. Okay, so that's about the code. Now let us submit our solution and see it. Yeah, so our code got accepted. That's about from this video, folks. If you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.